Hello everyone, in this video we're going to be solving a geometry puzzle. Alright, so please don't forget to comment, like, and subscribe. If you haven't subscribed to the channel yet, please hit the subscribe button and also the notification so you'll be notified of the new videos. Alright, let's get started. Two semicircles and a square with side length x are inscribed in a quarter circle with radius 1. Find x. That's all that's given, right? We do know that we have a quarter circle, its radius is 1, and that's it. And we do have a square, which has been shaded in this case. Okay, so let's go ahead and make some connections. We're going to start by finding, actually, the radius of the larger semicircle. And that shouldn't be too hard to find. Let's go ahead and start with that one. So I'll make one connection here. I'm not, actually, let me make it anyway. So I'm not gonna necessarily need it right away, but I might just as well show it to you. Okay, so this is, let's call this R, okay? Let's call this R. So this is going to be R as well, kind of like the height there. And obviously the diameter is going to be 2R here from this point to that point. Now that's the critical part. How do I find R? I make this connection. This is my center of the quarter circle. I'm gonna go ahead and connect it, okay? I'll go ahead and connect it to the point here, right here, all right? And then that's going to be the radius of the quarter circle, which is 1, obviously, right? And this is 2R. Notice that, okay? So I do have a nice equation here. This is a right triangle, and I'll probably erase that later not to get confused. But here's my equation. I have R squared plus 2R quantity squared is equal to 1 squared, which is 1, right? Okay, awesome. All right, so now let's go ahead and simplify this. This is going to be R squared plus 4R squared is equal to 1. Then from here, I get 5R squared is equal to 1, which means R squared is equal to 1/5. And if I square root both sides, I get 1 over root 5, which can be written as square root of 5 over 5 after rationalizing the denominator. So that's basically the first radius that I need to find, which is the radius of the larger semicircle. I'm going to use that later on, of course, for other things. But let's go ahead and take a look at the second semicircle here. Why do I need to find that? Because in order to be able to find the side length for the square, I'm going to need to find the radius of the smaller semicircle as well. Okay, cool. So let's see how we can proceed from here. We do know that the radius is actually here given, so we already have that. So I can go ahead and erase this. Let me clean up so that I can do my work. So now, this one too maybe. Okay. Now, what am I going to do to find the radius of this one? Well, here's the thing. You need to be able to make some connections, right? So we do know the radius. So what I can do is I can actually, let's see. Let's make this type of connection here. Since this is kind of, okay, how about this? Since this is the center, I'm going to make a connection like this one. I'm not even sure if this is going to help. So I'm just experimenting, okay? So let's see how this goes. Now, what does that give me? Well, that's going to give me a point. So let's not focus on the square right now. This is obviously what? The radius of the larger semicircle, right? Which is R. So I know that that's R. If you call this A, I don't know, any variable is fine, I guess. This is going to be A as well. Now, here's the million-dollar question. What's the hypotenuse, right? Well, the hypotenuse doesn't seem to be something that we might know. But here's the thing. Actually, we don't even need that. Why? Because we don't even need the Pythagorean theorem. Forget about this. Why? Because look at this. The whole thing from this point to that point is actually what? 1, right? So this is R, which is root 5 over 5. There you go. Okay. This one is root 5 over 5, which is radius, the larger one. And then the 2a plus this number is equal to 1. That's it. I don't even need to use the Pythagorean theorem there. So let's go ahead and write that down. 2a plus root 5 over 5 is equal to 1, which is the radius of the quarter circle. You see that? Between this point and that point. Wow, that was easy. Okay, cool. Now, how am I going to proceed? Well, we can subtract root 5 over 5 from both sides first, and then make a common denominator. That's going to be 5 minus root 5 over 5. And then divide both sides by 2, which is multiply the denominator. So a is going to be 5 minus root 5 over 10. Okay, so that is my radius for the smaller semicircle. Okay, awesome. I got that too. Now, what am I going to do? Well, I'm going to be making more connections, obviously, right? How am I going to make a more connection? Well, here's the one thing you can do, obviously. Connect the center of the quarter circle like this, right? Okay. And then drop a perpendicular here. So kind of like extend this. Okay, here we go. Extend that. And then let's see what else we can do from here. We can extend this as well, like here, right? Okay, so altogether, I think this should give us something nice. Okay, let's see what this gives us. Okay, all right. So, what do I have here? Well, if I call the side length x, which has already been called, right? That's x. From that point on, x, this I get a rectangle here. So this length right here is a. So this is a. Therefore, this is also a, right? And this is x. Awesome. So I got the a plus x there. This is a plus x. And I'm getting a right triangle, don't I? Okay, so this is a plus x. Now, what about the height? Well, the height is going to be, this is x, this is root 5 over 5. So the height would be x plus root 5 over 5. And the base is going to be x plus a. But remember, I know the value of a, so I can actually go ahead and substitute that. Okay? So I know that. What about the hypotenuse? Hypotenuse is awesome because it's going to be the radius of the quarter circle. Therefore, it's going to be 1 as well. So basically, I'm working inside this right triangle here to solve for x. Okay? So let's go ahead and proceed. What am I going to write? Let's go ahead and change colors here maybe. So let's make some room. Okay. I have x plus a squared, but I do know that a is equal to this number here. So let me write it that way first. X plus a squared plus x plus root 5 over 5 squared. Root 5 over 5 squared. And that should equal 1, right? Which is the hypotenuse here from this point to that point. Right there. Okay? That's my right triangle. Awesome. So I have everything I need. What I need to do now is basically replace the a with what it is and then solve this quadratic equation. So I have x plus 5 minus root 5 over 10 squared plus x plus root 5 over 5 squared, and the whole thing is equal to 1. All right, cool, awesome. Now, we can expand this. We can arrange the terms. We're going to get 2x squared plus blah, 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 so on and so forth. There's going to be a lot of constants, a lot of radicals, so on and so forth. So I'm going to spare you all that trouble and give you the x value. Obviously, we're getting two values here, one of which is negative, and that's not acceptable because x is the side length of the square. So x from this equation is going to look like, and you're going to be kind of surprised with this result because it doesn't look very simple. It's going to be negative 5 minus square root of 5 plus the square root of 130 plus 30 root 5 all over 20. Okay, so that's going to be my x value for this equation. And that's it that's the side length for the square. Thank you for watching. And I'll see you in the next video, which is going to be a challenging math problem. Until then, be safe and take care. Bye-bye.